Alright guys, you have learned all the exponent rules that you need to know. Now we're going to combine them. Okay, so far the problems have been pretty basic, like one-steppers. These problems are going to be multi-step now. Okay, now the good thing is, and we want you guys to be creative, is there's more than one way to approach these problems. So don't think you have to do it a certain way. Just use your intuition and you should be fine. Okay, so number one, what I'm thinking when I look at this one is, first of all, anything to the 0 power is 1. So all this stuff in this parenthesis, I can kind of like just cross it off because it's all just a big times 1, right? Okay, so one way to do it is by using the rules. And the rules state, let's give the 2 an exponent of 1, right? And the rule said if you have a power to a power, you distribute by multiplying. Okay, so we have a 2. 1 times 5 is 5. And then we have an x. 5 times 3 is 15. Okay, and then you could put times 1, but it doesn't really do anything. So I'm just going to leave it like this. And then, yeah, that's it. 2 to the 5th power is 32. So it's 32x to the 15th. That's one way to do it. Let's try another way. Another way would be, I would still start here. Anything to the 0 power is 1. The other way would be, if you don't like the rules, to actually just write it out. It's 2x cubed 5 times. Maybe some of you, this makes more sense. Okay, so 2x cubed 5 times. Well, let's see what that is. 2 times 2 times 2 times 2 times 2 definitely gets you 32. And then remember the rule, when you're multiplying same bases, you add. 3 plus 3 plus 3 plus 3 plus 3 is x to the 15th. All right, so there's 2 ways to do that first problem. Both are totally acceptable. Now, you guys, I'm going to change number 2. I'm going to make this one a little bit different. Can you all change this with me? Let's make this one 2a5 over 4a, and then let's have it to the 3rd power. Okay, so let's do it 2 different ways. The first way is that we could distribute right away. So we can give the 2 a 1 and the 4 a 1, and we could say, okay, when you have a power to a power, oh, let's give the a 1 also. You distribute and multiply, power to a power. So this would be 2, all right, well, 3 times 1 is 3. And then it'd be a to the 15th. And then on bottom, it would be 4 to the 3rd. And it would be a to the 3rd. Okay? And then to go from here, you would actually evaluate. 2 to the 3rd power is 8. So it'd be 8, a to the 15 over 4 to the 3rd power is, I think, 64, a to the 3rd. And then you would have to reduce. 8 over 64 reduces to 1/8. And then remember this rule, when you divide same bases, you subtract. 15 minus 3 is 12. Okay, so that's the answer. Some people might have it written a little different, but that's one way to do it. Let's try it another way. So the other way is, what if you wanted to reduce first? So let's go ahead and reduce the parentheses first. Well, 2/4 reduces to 1/2. And then Dividing same base as you subtract, so 5 minus 1 would be a to the fourth. Okay, and then now we can do to the third power. Okay, so let's give our bases exponents of 1, since nothing's there, and then power to a power we multiply. Okay, so we have 1 to the third power, a to the 12th power, and then 2 to the third power. And now we just have to evaluate these. 1 to the third power is just 1. So we have 1a12 over 2 to the third power is 8. So notice how we get the same answer? Two different ways. Another way even is you could just write it all out and just start canceling things. All right, guys, moving on. Let's try, let's do number 5 instead of 3. I don't know why this is called number 5. Okay, let's see what we got here. So the first way that I'm thinking of is to give this a 1 and do a little power to a power distribute multiply. So it'd be 3 to the third, x to the negative 6, y to the 6th. Because power to a power, you multiply exponents. Okay, and then next I would say let's evaluate. 3 to the third power is 27. X negative 6, y 6. Okay, and then lastly, no negative exponents are allowed. So if your exponent's negative, you got to drop it like it's hot. But don't move the 27 and the y6, only the base with its negative power. So final answer, we still have the 27 and the y6 on top, but the x to the 6 drop, and when you drop it, it becomes positive. Okay, so that's that one. Let's see if we can figure out another way to do this one. Another way is to clean up the inside first. And what I mean by that is, okay, we have the 3 to the 1. What if we drop the negative x right away? So what if we drop it like it's hot, and then we leave these guys on top, and then later we distribute the 3? That's another way to do it. Okay, so we got rid of the negative exponent right away. Now, power to a power we multiply. Let's see if this is any easier. Okay, so we have a 3. We multiply 1 times 3 is 3. For the y, 3 times 2 is 6. And then for the x, 3 times 2 is 6. And then you just have to evaluate any numbers. 3 to the third power is 27. So it's 27, y6 over x6. That's it. All right, if you guys are feeling like you can't do any more, feel free to stop right here. If you want, though, I will do number 3 up top. And I don't know if I can only think of maybe one way to do this one, so we'll just do this one way. Okay, now on this one, we probably have to start by distributing. So give it a 1, give it a 1, give it a 1, give it a 1, and we're going to do a distribute, power to a power you multiply. All right, so we have 2 to the 3, s to the 3, over 3 to the 3, t to the 3, and then this guy, nothing to do, right? t5 over 16. Okay, that's how you have to start this one. And now, let's see, one way to do it would be to, well, let's evaluate these. So 2 to the third power is 8, s cubed, and 3 to the third power is 27, t cubed. And then I'm just going to copy it down. The next thing I would do would probably be to reduce. So like 8 over 16 reduces to 1/2. And then whenever you guys are multiplying, you could just extend the fraction bar. And then the rule says if you're dividing same bases, you subtract. So 5 minus 3 is 2. Okay, so these also reduce and become T2. Okay, I know it's a little messy. Let's rewrite it. Final answer now is on top we have 1 S3 T2, and on bottom we have 27 times 2, which is 54. Okay, that's one way to do that one. I think that's really the best way to do it. There's tons of other ways. If you guys really want, if you still want to watch, I'll write it out the long way if that helps. So let's see. We have 2s over 3t. We have that 3 times. 2s over 3t, 2s over 3t, 3 times, and then we have a t5 over 16. But let's actually write it out. T to the 5th would be 5 of the t's. Okay, guys, let's see what we got here. So these t's cancel, these t's cancel, these t's cancel. So on top we're left with 2 times 2 times 2 is 8. We have 3 s's and 2 t's, and on bottom 3 times 3 times 3 times 16 is 432. But then we'd have to reduce this. If you reduce 8 and 432 by 8, you end up with 1 over 54, s cubed t squared. So yeah, we end up with the same answer. It's just different ways to do different problems. All right, nice job, guys. That was combining using all the rules.